Part 1, the call at 2:17 a.m., somewhere deep underground, a phone rings, not a ringtone, not a buzz. A hard mechanical tone that cuts through concrete and steel. Like it owns the place. Two officers turn their heads at the same time. They already know what it means. This is not a drill. Or at least, they don't know yet. Part 2, the truth about how it starts. Here's the part most people get wrong. Nuclear war doesn't start with a missile. It starts with a decision. A human one. And everything that follows, it's a chain reaction of systems designed to remove doubt. Remove hesitation and remove time. Minutes. That's all you get. Sometimes less. Part 3, the global arsenal. Right now in 2026, there are roughly 12,500 nuclear warheads on Earth. About 90% belong to just two countries, the United States and Russia. And both sides maintain something called launch on warning, which means if their sensors think a missile is coming, they don't wait to get hit. They fire back before impact. Let that sink in. Part 4, the system. So how does it actually happen? Step by step. From the first signal to the moment a missile leaves the ground. Because once you see the process, you realize something uncomfortable. It's not chaos. It's procedure. And it's been rehearsed for decades. Part 5, detection. Step 1, detection. Not by humans. Not at first. By satellites. Specifically systems like the U.S. space-based infrared system. Each satellite sits 36,000 kilometers above Earth. Scanning for heat signatures. Not explosions, not smoke. Heat. The moment a ballistic missile ignites, its rocket plume burns at over 3,000 degrees Celsius. That's brighter than the surrounding Earth in infrared. So the satellite sees it instantly. Within seconds. Part 6, false alarms. But here's the problem. Satellites don't know what they are seeing. They detect patterns. And sometimes, patterns lie. In 1983, a Soviet early warning officer named Stanislav Petrov saw his system report 5 incoming U.S. missiles. 5. The protocol said report it up the chain immediately. Nuclear retaliation could follow. He didn't. Why? Because he thought it didn't make sense. The U.S. wouldn't start a war with just 5 missiles. He was right. It was a false alarm caused by sunlight reflecting off clouds. 5 fake missiles. 1 human decision. That's how close it got. Part 7, confirmation. Step 2, confirmation. Because one system is never enough. Once a satellite flags a possible launch, ground-based radar kicks in. Systems like the U.S. PBWCs or Russia's Voronezh radar arrays. These are massive installations. Some can track objects over 5,000 kilometers away. They don't just detect, they calculate trajectory, speed, impact point. Is this missile headed toward you or somewhere else? That matters, because launching a nuclear counterattack based on a mistake is irreversible. Part 8, the clock. Now you've got 2 independent systems saying the same or not. If they disagree, you pause. If they agree, the clock starts ticking. An intercontinental ballistic missile takes about 30 minutes to impact. A submarine-launched ballistic missile, maybe 10 to 15 minutes. That's it. Decision time shrinks fast. Part 9, leaderships. Step 3, escalation to leadership. Now humans take over. In the United States, the data goes to the National Military Command Center. Also to STRATCOM, Strategic Command. In Russia, it flows to the General Staff in the Kremlin. Within seconds, senior officers are reviewing the data. Within a minute, the president is being notified. No delays. Right now. Part 10, the decision. Imagine you're the president. You've just been woken up. It's dark. Your brain is still catching up. And someone tells you, we have detected incoming missiles. Estimated impact in 18 minutes. That's not a hypothetical. That's the briefing. Part 11, the football. Next to you is a military aide carrying the nuclear football. Inside, communication tools, authentication codes, and response options. These are not improvised. They've been prepared in advance. Strike-only military targets, strike military and industrial targets, or full-scale retaliation. Hundreds of warheads, different levels, different consequences. Part 12, the plans. These plans are called O-plans, operational plans, and they are detailed down to individual targets. Missile fields, air bases, command centers, cities, each target assigned a specific warhead. Each warhead assigned a delivery system. It's all mapped out, cold, precise, pre-decided. Part 13, authentication. Step 4, authentication, because no one person should start nuclear war without verification. In the U.S., the president carries a card called the biscuit. On it are codes. When the president gives an order, those codes prove it's really them. The system challenges. The president responds. Match confirmed. Authority verified. Part 14, the silos. Meanwhile, down in missile silos, crews are waiting, 2 officers per silo. Always 2. This is called the 2-man rule. No single person can launch a missile alone, ever. Each officer has a key. They're spaced apart physically, because one person can't turn both at once. Part 15. The order. Step 5. The launch order. If the president decides to proceed, the order is transmitted, encrypted, sent through multiple channels, landlines, satellites, radio. Redundancy is everything. Part 16. Final check. In the silo, the crew receives a coded message. It looks like random characters, but it's not. They compare it to a sealed authentication system. If the codes match, it's real. Not a drill. This is the moment. Part 17. The turn. They open a safe inside the launch keys and final instruction. Everything is procedural. No improvisation, no debate. They've trained for this hundreds of times, but never for real. Until now. On command, both officers insert their keys. They turn them. At the same time, they hold the keys turned for several seconds. Part 18. Ignition. One silo alone doesn't launch the missile. It takes multiple crews across different silos, all confirming the same codes. Only then does the system proceed, layer after layer, check after check. Because once it goes, there's no calling it back. Now we're seconds away. The missile is fueled. Guidance systems active. Readiness loaded. The target already chosen minutes ago. And then ignition. Part 19. Launch. A column of fire erupts beneath it. The missile weighs about 36,000 kilograms. It accelerates to over 24,000 kilometers per hour. That's Mach 20. Within 3 minutes, it's in space. The boost phase ends. The rocket stage separates. And what's left is not one weapon, but many. Part 20. ARVs. Modern ICBMs carry MARVs, multiple independently targetable re-entry vehicles. One missile, up to 10 warheads, each aimed at a different target. Cities, bases, infrastructure, all from a single launch. Part 21, the reality, and that's where most explanations stop. Launch, fire, impact. Simple, but the truth is, everything you've just seen, that's only half the story. Because launching is the easy part, surviving what comes next. That's something else entirely. Part 22, re-entry. Once those warheads separate in space, something strange happens. Silence. No engines. No flames. Just objects falling at 7 kilometers per second. That's over 25,000 kilometers per hour.
You don't hear them coming.
You don't see them until it's too late. Part 23. The warhead. Each one is called a re-entry vehicle, a cone-shaped shell wrapped in a heat shield. It can withstand temperatures above 7,000 degrees Celsius. That's hotter than the surface of the sun. Inside, a nuclear warhead. Typical yield, 100 to 475 kilotons, for something like the US W-87 or W-88. For comparison, the Hiroshima bomb was about 15 kilotons. So each one of these is 6 to 30 times more powerful. And there can be 10 of them from one missile. Part 24. Impact. Step 7. Impact. But impact is misleading. Most nuclear warheads don't actually hit the ground. They detonate in the air, about 300 to 1,000 meters above the target. Why? Because that's how you maximize damage. The blast wave spreads outward in every direction, flattening buildings over several kilometers. A 300 kiloton airburst can destroy most structures. Within a 5-kilometer radius, glass shatters even farther out, and then comes the flash. Part 25. For a fraction of a second, the center reaches extreme temperatures, several million degrees Celsius, hotter than the core of the sun. Everything nearby vaporizes. Concrete, steel, people, gone. Part 26. Shockwave. Then the shockwave hits. It moves faster than the speed of sound at first. Buildings don't just collapse. They're crushed inward, like stepping on a soda can. Part 27. Heat, and then the heat. Thermal radiation spreads outward at the speed of light. At 3 kilometers, exposed skin suffers 3rd-degree burns. At 10 kilometers, flammable materials can ignite. Entire neighborhoods catch fire at once. This is how firestorms start. Oxygen gets sucked into the flames. Winds reach hurricane speeds, and the fire feeds itself. There's no escaping that. Part 28. Fallout. Then comes the mushroom cloud. Not just a symbol, a physical process. Hot air rises rapidly, pulling debris, dust, and radioactive particles upward, up to 15 kilometers, sometimes higher. This is fallout, and it doesn't stay put. Part 29. Spread. Wind carries radioactive particles hundreds of kilometers away. Downwind areas become contaminated. Places that weren't even targeted. Radiation sickness. Cancer risk, long-term environmental damage. The effects last years, decades, sometimes longer. Part 30, scales. Now here's where things get even darker. Everything we just described is one warhead. One. Modern nuclear strategy doesn't use one, it uses many. Dozens, hundreds, launched within minutes of each other. This is called a strike package, and it's designed to overwhelm. Part 31, escalation. Remember launch on warning. Here's the consequence. If one side detects incoming missiles, they launch their own before impact, which means both sides fire, almost simultaneously. Even if the first alert was wrong, that's the system. No pause, no reset. Part 32, submarines. And it's not just silos. There's a second leg of nuclear forces, submarines. Ballistic missile submarines carry nuclear missiles. Each one carries 16 to 20 missiles. Each missile can carry multiple warheads. And these submarines are hidden somewhere in the ocean, always moving. Part 33, second strike. You don't know where they are. Your enemy doesn't know either. That's the point. Even if land-based missiles are destroyed, these survive and they retaliate. Guaranteed. This is called the second strike capability. Even if you hit first, you still lose. Part 34, bombers. There's a third leg too. Strategic bombers. Aircraft like the B-2 Spirit or Tu-16. They carry nuclear bombs or cruise missiles. Slower than missiles, but flexible. They can be recalled mid-flight, which makes them unique. Everything else, no turning back. Part 35, the system. Now step back. Look at the whole system. Satellites, radars, command centers, missile crews, submarines, bombers, all connected, all designed to respond in minutes, not hours, minutes. Part 36, speed over certainty. And this is the part most people miss. The entire process is built around speed, not certainty. Speed. Waiting for confirmation risks losing the ability to respond. So the system accepts risk, huge risk, false alarms, misinterpretations, human error, all of it. Because the alternative is worse. Part 37. The insight, and that brings us to the real insight. The thing that ties all of this together, the aha moment. Most people think nuclear weapons are about destruction, bigger bombs, bigger explosions. That's not what they are really about. They're about timing and fear. Part 38, decision time. The entire system forces decisions faster than humans prefer. You have 30 minutes, then 20, then 10 point. And suddenly, you're deciding the fate of millions.
In less time than a sitcom episode.
That's the design. Because hesitation is seen as weakness, and weakness invites attack. Part 39, the exception. Remember Stanislav Petrov? The Soviet officer who ignored the warning in 1983? He broke the system. He chose to wait. And he may have prevented nuclear war. But here's the uncomfortable part. He was not following protocol. He was violating it. And if he had been wrong, his country might have been destroyed. That's the gamble. Part 40, defense. Now you might be thinking, what about missile defense? Systems that shoot down incoming warheads. They exist. The U.S. ground-based mid-course defense system. Israel's Arrow system. Others. Like, here's the reality. Intercepting a nuclear warhead is like hitting a bullet with another bullet in space at 25,000 kilometers per hour. It can be done, sometimes, but not reliably enough. Not for large-scale attacks. Part 41, decoys. And it gets worse. Modern missiles deploy decoys. Fake targets that look identical on radar. So defenses don't know which one is real. They have to guess. And guessing is not a strategy. Part 42, the world. So where does that leave us? A world with thousands of nuclear weapons on standby, ready to launch in minutes, controlled by systems designed for speed, balanced on deterrence. The idea that no one will use them, because everyone knows what happens if they do. It's worked so far, barely. Part 43, the paradox, because the real weapon isn't the missile. It's the threat of the missile. The knowledge that once the process starts, it doesn't stop. And that's the paradox. The most powerful weapons ever built are designed never to be used. Because if they are, there is no next step, only aftermath.